When we plug the PlayStation 5 controller, the DualSense, into HID remapper and go to the Monitor tab on the configuration website, we can see all these inputs from the sticks and the buttons, and we could of course remap them however we want. But some things are missing. For example, there are no inputs from the touchpad, and also this controller has motion controls, an accelerometer and a gyroscope, and there are no inputs from those here either. Why is that? It's because even though the DualSense is sending that information, HID remapper doesn't know where to look for it. The way USB input devices work is that every time they have something to report, for example when you press a button or you move the joysticks, they send some bits to the computer. But the format of those bits is not fixed. Every device is free to define it within certain rules. So how does the computer know which bits correspond to which inputs? There's this thing called HID report descriptor that every USB input device has, and it says which bit means what. It says where to find the current state of every button and every axis in the bits that it's sending to the computer. Back to the DualSense. The problem with it is that its report descriptor is not as good as it could be. It says where to find the button state and the joystick state, but it doesn't have proper definitions for the touchpad or the motion data. The information is still there, but it doesn't properly advertise where to find it. You might ask, how does a PlayStation 5 know where to find that information in the bits sent by the controller? Well, it just knows. It has that information hard-coded in its system software. But HID remapper has to work with all input devices. It can't have the data formats for every device hard-coded in its firmware. What it can do, though, is allow the user to add custom definitions for some inputs that are not exposed properly by the device. Essentially, add workarounds for broken or, let's say, imperfect HID report descriptors. These custom definitions can be added here in the Settings tab. They are called custom usages. A usage is just a name that the HID specification uses for inputs, or I guess also outputs. It doesn't matter. What matters is that we will add some stuff here, and then HID remapper will be able to see things like the touchpad or the motion data on the DualSense. These custom usages allow us to provide the information that's missing from the report descriptor of the device. They allow us to say, for example, the touchpad data is located here and uses these many bits. Where do we get the necessary information? We could plug the DualSense into our computer and use software like Wireshark to view the raw data coming from the controller and try to guess which bits correspond to what, which is not terribly hard. Usually you can figure things out just by looking at the changing data. Or we find the necessary information on the internet. Let's try and do that. Let's Google DualSense report descriptor touchpad. Now I have done this before, so I know that the answers we seek are on this page. Let's try input reports. This is the structure that we'll ultimately want, but where is it in the report? This is the report structure, and we can see that at byte 32 there's touch data, which was defined above. Touch data contains two instances of touch finger data. It's because the touchpad is able to report two finger positions at the same time, so we could in theory do stuff like pinch to zoom. And touch finger data contains the actual data. The first byte contains the finger index and a bit that tells us if the touchpad is currently touched. And then there's 12 bits for the X coordinate and 12 bits for the Y coordinate of the touch point. Let's try and access that. Let's ignore the index and the flag for now. Let's only define usages for the X and Y. Let's ignore vendor ID and product ID and the interface number for now, though they are important if you want to connect more than one device at the same time, or if your device has multiple interfaces. The data that we're interested in has a report ID of 1. Size is 12 bits for each coordinate. Position is in bits as well. We know that the touch data starts at byte 32. 32 times 8 is 256. And there is an additional offset of 1 byte. So 256 plus 8 bits is 264. This should be the position of the x coordinate. And the y coordinate is 12 bits further, so 276. Okay, we need to assign some usage codes for these two inputs. It doesn't matter what they are, as long as they don't clash with other existing inputs. I'm going to use FFFF0001 and FFFF0002. Let's save that. After defining custom usages, we need to replug our device. And let's see if the touchpad data shows up in the Monitor tab. We're looking for FFF0001 and 0002. And here they are. When I touch the touchpad, the numbers are changing. Okay, let's do something with this data. Let's make some expressions that will compare the current position to the previous position and use that to move the mouse cursor. Expressions are little programs that can be used in situations like these to perform some simple calculation, or sometimes not so simple. The syntax is a bit weird. It's basically reverse Polish notation. You can read more about it in the documentation on the project GitHub repository. Okay, let's try to create an expression for this. Let's fetch the current state of the x coordinate of the finger touching the touchpad. FF0001 input state. Let's fetch the previous state. There's no way to subtract numbers, only add them. So we're going to multiply this by -1 and then add the two numbers. The result is the x delta between the previous touchpoint and the current touchpoint. Let's map the result of this expression to cursor x. And let's do the same thing for y. Change 1 to 2. Map this to cursor y. Save the configuration to our HID remapper. And let's see if it works. It does work, though not without some issues. When I stop touching the touchpad and then start touching it in another spot, the cursor jumps around. That's because we have totally ignored the finger indexes and the flags that tell us whether a finger is touching the touchpad or not. But it's a good start. If you go to the Examples tab, there is a more complete example there that takes all of this into consideration. Let's load that. Save it to our HID remapper. Unplug and replug the DualSense. and see what it looks like now. It's working much better. The cursor no longer jumps around, and you can also use 2 fingers at the same time. Though it doesn't understand any gestures like pinch to zoom or anything like that. This example also has custom usages for the motion data on the DualSense, the accelerometer and the gyroscope data. Let's quickly take a look at that. You can see that as I rotate the controller, these numbers change. These are the accelerometer numbers, and these are the gyroscope numbers. Okay, let's take a quick look at the expressions from this example. They're slightly more complex than the ones that we have written earlier. In addition to getting the position deltas from both data points, they also check if the finger indexes match, and they check if a finger is currently touching the touchpad. Okay, that is it. For more information on the expression syntax and HID remapper in general, see the project's GitHub repository. If you have any questions, please leave a comment. Thanks for watching.